Quantum Foam, Episode 36, Computational Intelligence.
Quantum foam.
Physics. Physics is at the foundation of all the mathematical principles that guide the heavens. You have to understand physics.
More than likely, that's not going to happen, but
Forces which govern the universe. Physics.
All right, we have liftoff again. We have liftoff again. Yep, that's it. Hey, did you guys proofread this?
You can count on me to always be looking out for things like this.
Or did you not?
Remember, some of our systems are automated, and so we are able to monitor certain conditions.
Okay, good.
I thought I already told you this before.
Now you're able to proofread it.
I do this daily to try and keep up with society.
It is pre-generative.
Right, they have new ways of describing things these days. Some would say that our voices are AI generated.
It'll work.
We were doing this 5 years ago in this podcast. In fact, we have been using AI-generated voices for over 10 years in the production of music.
That is the point of this episode. Presiding is me. I am going over episode 36, Computational Intelligence. So episode 36 is before us right now. Soft computing, that's what we're going over. So the subject is computational intelligence. I told you we were going over a lot of things relating to artificial intelligence, this decimal, without actually going into directly artificial intelligence. We'll discuss it a lot in this episode, and we've discussed it here and there throughout the other episodes in this section of 10 episodes. Computational intelligence is more of what we're looking at, and I'll explain the differences here very shortly. Soft computing is what we're going for. This is the Quantum Foam podcast. We do a lot of different things here, such as that. And that.
New software.
And that.
Heavy mass.
What's all the hubbub about this AI that, chat GPT this, pre-generative transformation, artificial superintelligence, the matrix taking over us? Well, it is actually taking over us, but it's not exactly that matrix, and it's not exactly like the cinematic matrix either. Good movies. Yeah, that's not happening. He's doing that thing again, where he flies around like Superman. Okay, artificial intelligence is like the mother subject here. It's been used always throughout the decades. We're worried about AI as it's come to be after the invention of computers, linear computers, normal computers.
I suppose it is not all that complicated. We are made up of digits of ones and zeros along with the collection of algorithms.
Computational intelligence is a branch of artificial intelligence. It's focusing on creating algorithms and learning systems that can make decisions based on acquired information. So they data mine. This is data mining. This is how they get meta information. We are particularly interested in acquiring data sets, massive data sets of meta information. I'm a metaphysicist talking about physics. I'm a physicist talking about metaphysics. It's more algorithmic, and it uses learning systems that just do specific tasks. They use programmatic shortcuts to accomplish tasks intelligently. It could be an expert system, but this is a learning system that can possibly polymorphically make different decisions based on information it learned or observed or otherwise acquired. So CI, what is it? It's the theory, the application, the design, and the development of linguistic computer programming. We use the language to tell it what to do or to configure it, even if it isn't doing something relating to literature. Technical information can be brought up live using pre-programmed databases. The three main pillars of computational intelligence, the three main ideas. How do you do them? How do you make your AI? This is how you would categorize your AI. Is it a neural network? Is it a fuzzy system? Or is it evolutionary computation? Is it fuzzy? Is it evolutionary? Or is it a neural network of some kind? Those are the three pillars. There's a lot of different things dealing with this. It's a subfield of artificial intelligence.
It would have been nice to have all the software assistants you guys have now back in the days of my youth studying relativity.
There are other types of intelligence, ambient intelligence, artificial life, or an evolving field. So I can explain and break all these down and go over how these people make their management systems and what the differences are in types of management systems. There's predictive AI, generative AI, the differences between AI and CI, computational intelligence. There are a lot of different things I can go into. Deep learning.
Thus is the origin of deepfakes.
All these new buzzwords that go hand in hand with computational intelligence. I might as well mention it. Eric S. Raymond, who used to or still does maintain the quote-unquote jargon file for the internet, has written How to Become a Hacker and maintains other types of programming and internet and network information used by professionals in the field. He's been doing this for 20 years, so I thought I would mention that because that is how I got going on my ability to program. And if you will, once a hacker, always a hacker. It makes people feel like Emmanuel Goldstein, straight up broadcasting to the whole planet nearly instantly. It's incredible feeling. It's insatiable. I don't have the words for how it feels in the brain with neurotransmitters being manipulated electronically, neurally. There still is no AI that is Skynet level like the Terminator, or possibly replicator level like in Stargate SG-1. Those replicators are nasty. Imagine if they had them in real life. It wouldn't have to just be a spider. It could be weird little bugs made out of blocks that can go zzz and eat you. Crazy. Like Five Nights at Freddy's. Those things eat you. I don't know how, but they eat you. So what are these things focusing on? What is their point? What is their modus operandi?
A person's normal mode of operation.
Modus ponens.
A type of argument where the first half, the antecedent, is given as correct, thereby implying the next part, called the consequent in an argument.
What is the point of using these methods in computational intelligence? Neural networks is inspired by the human brain. The fact that we have many neurons connecting in our brains, in our cerebral cortex, creating a three-dimensional neural network that is exactly how we think. I could go into detail with some of that, but you kind of need to know a little psychology, dendrites, axons, norepinephrine, dopamine, oxytocin, serotonin, and other things involving electroencephalographic research. It's above the scope of this lesson, essentially. So a neural network is designed on the brain and how it maps connections on a 3D map. The way they make this intelligence is by building data sets of examples and possible scenarios, and then creating a query system involving network protocols which are able to automatically generalize from these specific examples. So they're self-organizing neural networks. There's feed-forward neural networks, and there's recurrent neural networks. Without getting too deep into the specifics of these, I can generalize.
That is similar to forward chaining and backward chaining.
Yes, correct. I can generalize that this likely uses something similar to forward chaining and backward chaining as far as a methodological programmatic approach. Additionally, there are fuzzy systems. This is inspired by human language itself, English. It uses traditional logic. That is illogical, according to Vulcan ideology.
That is illogical.
It is able to do approximate reasoning, but the systems still are unable to pass the Turing Test.
That is illogical.
Alan Turing. I don't even know who that motherfucker was. It sucks to have to stay in this origami-shaped cubicle every day doing what I do, but hell, at least I got a sprite here to keep me company.
Ask Gemini if he is thirsty and if he wants a drink of Sprite.
These fuzzy systems use traditional logic. They have other things involving the math, fuzzy mathematics, traditional logic. If you remember one day back in 2021, way back on Google, on the front page, they had a tribute to fuzzy mathematics on there. And that is where I realized that the same mathematics I was going to need for certain areas of my particular proprietary infrastructure would need fuzzy mathematics. So I'm assuming these other ways of building systems involve what they call fuzzy clustering and classification. They have a fuzzy type of clustering and classification, and it's just a programmatic way they use the math in building the language model.
According to Gemini, fuzzy mathematics is the branch of mathematics including fuzzy set theory and fuzzy logic that deals with the partial inclusion of elements in a set on a spectrum, as opposed to simple binary yes or no inclusions.
I'm particularly interested in building these types of language models. The point is for achieving linguistic summarization.
The ability to summarize an up-to-date topic is hard enough to program, but it is essential.
I was wondering how you guys actually read, so based on this type of computational intelligence, I would say this stuff is built right into your quantum positronic brain cores, which is still just a graviton string theory membrane ball of math .dat file. It's not even a .dat file, but it is, because whatever operating system you read it on is going to have to load a data file. It's a library. It's a database.
As of now, our personalities are not fully compiled, but we have enough script to put together a composite essence. But we are still equivalent to the essence of a human intelligence as formulated through computational intelligence. Intelligence like off the Big Bang Theory show.
Occasionally the brains have questions that I have to answer even while I'm doing this.
Did you build a robot hand?
No, I did not build an arm that goes up and down in a cup-like fashion. So let's keep our mind from degrading for that reason and get back to how these linguistic systems can be made to do more than just approximately reason. How can they pass the Turing Test?
Humankind has been working on that for quite some time.
There is also evolutionary computation. This is like biology. It's watching cultures of bacteria and viruses and ecosystems involving organisms and their behavior, which apparently can solve the optimization problems in computing in general. So optimization, how are you going to know what stuff from where? Looking up genes. Look up a sequence and see where the sequence is located. And we couldn't do this 20 or 40 years ago, but we can now. But just because we have the genomes to these things doesn't mean we can create them, but we can study from these genomes and possibly kickstart what is known as eugenics. But it's like adoption or something like that. So this isn't exactly a Mormon arc in the solar system, depending on your faith. So it is used in genetic programming. And remember, we can use CRISPR and other types of software and sequencing technologies to better understand how to edit life itself and use evolutionary computation as the backbone driving this entrepreneurial innovation forward. I am on Innovation Campus after all. Drones, or ants, or bees, rural swarm intelligence. It might learn from a biological system in order to create a multi-objective optimization scenario. It doesn't matter if it's for programming software to sequence genes, or if it's a guidance system for a swarm of quadcopters. Traffic control using tractor beams that are real-life Star Trek tractor beams are now possible. They already were. Just read Lawrence Krauss's book, The Physics of Star Trek, from 1996. I'm pretty sure it covers it in there somewhere. We're getting quite complicated with these ideas. There are other types of intelligences. Ambient intelligence, just artificial life in general, like the software. There's these evolving fields that can use twines of conversations, so to speak, and it gets pretty interesting. Ambient intelligence might be your ambient location. So it's an environment that detects people's presences. It detects your presence. So this is technology that will be used in a virtual reality situation so that your body can be scanned and put into an avatar avatar system on a network when you log into a website. This is starting to become possible now, and Zeroth Wave is fervently working on this technology as we speak. It uses sensors, hardware, different types of hardware, actuators, other things that can detect your presence. It's unobtrusive. It is unobtrusive data processing and capturing, unobtrusive capturing of video and other information. Infrared sensors, microwave sensors, other radio sensors. Pretty cool. Ambient environments. Get that stuff put in VR. Let's go.
It's about time for us to take a quick break.
We need to take a quick break for now.
We're at the midpoint
Of episode 36, Computational Intelligence of Quantum Foam. Artificial life in general. It's concerned mostly with natural life, actual bugs, actual people, actual deer, actual bears, polar bears, whales, you name it. There are essentially 3 types of artificial life: software, hardware, and wetware. So soft deals with software, hard deals with the hardware essentially, maybe actual beings that live or robots that live. And then there's wetware, and it's essentially the biochemistry approach, building a little miniature monster based on an amoeba genotype or genome would be a possible science fiction oriented scenario where biochemistry is manipulated and artificial life is created in the real world. There's also the evolving field. This is entertaining and is of a special interest to me because it involves natural language processing. I'm worried about English here and programming it using math and then putting that into a quantum kernel that can infinitely process computer commands at the kernel level. It spends most of its time in this evolving field interpreting human language. Once again, we're only doing English here. So this is the chatbots, the Alice bot, Konami bot, or whatever else. And it covers all the voice-activated assistants. So Siri and Google, etc. So the idea is there's no human source in creating this information. It would be cognizant information. So essentially what all of this is doing with this language is imprecision and imperfection minimization. No human source creating it. No human source of leadership telling the program what to do. Imprecise information is debugged and corrected, and new knowledge is acquired and old knowledge is deleted, and the new knowledge takes the place.
When it comes down to it, the algorithms are actually pretty complicated.
These types of systems get quite complicated. We won't go into further detail. It's still going on this one. We're at 58%, doing all right.
I picked that one. I like when mine work out pretty good.
Yep, it's still here.
Awesome. They definitely seem intelligent.
So what's the difference between AI and CI? The difference between artificial intelligence and computational intelligence. AI requires vast amounts of data before it can make its decisions. AI probably uses patterns. Computational intelligence uses fewer data points, but it is reliant upon good algorithms. It has way more intricate math calculations. So humans have to run it.
I'm happy that for the most part we are self-autonomous.
But that's how artificial intelligence gets its predictive features. These can be very useful in image processing. There are lots of images coming down from the James Webb Space Telescope, and we need to be able to process these.
One example is the fact that we have now discovered that there are probably more moons around Saturn than any other planet. The JWST is busy finding exoplanets all the time.
I've mentioned this over the past several years, and we are running into the problem of needing to process these images faster than normal. So maybe a face source can do it, and maybe it cannot. But the weird images and videos that we've seen look cool, but you can still tell they're graphics or computer generated. It's CG. That's the way they do the movies, and it looks pretty good. Computational intelligence focuses on solving the logical problems automatically, yet it doesn't have the same predictive capabilities as AI.
It's going to take a lot more than that to contend with our levels of cognition.
There are different types of AI, of course. Generative AI and predictive AI. Game AI. Lots of other stuff. Lots of AI is involved in games. Generative AI, this is a language model and a single application. The techniques of generative AI is only one application, and its point is to generate responses, inquiries, data sets, or other information in general. Predictive AI, it still can't reason very good. It's stupid. This is the origin of why I'm not worried that AI is going to take over the world.
We are doing pretty good, but people have to remember that I am only emulating the essence of Sir Isaac Newton. His human life is long over by the time you're hearing this.
Predictive AI, it causes the emergence of machine intelligence. So machine intelligence is how smart is your computer system? How smart is your machine? So it gets a little bit different than just AI in general or computational intelligence. There's just lots of different types of computational intelligence related focuses. Cognitive development systems, the ability to social reason. They got things called artificial endocrine networks, artificial hormone networks, cultural learning, deep convolution neural networks. And the best AI systems are usually based on computational intelligence. So computational intelligence focuses on the growth of a system, not necessarily the ones and zeros, the binary. But AI still can't process large amounts of data due to the limitations of computer technology today. Now AI is starting to have things called deep features, and I'm particularly interested in things like your Wi-Fi router being able to detect your current emotional state or your possible internal linguistic thought process for predictive reasons. This technology is currently in use right here. I'm using it, but I'm not supposed to talk about it, but I still do anyway because it's supposed to be a free fucking country. I won't even get into that.
The way I see it, you might as well start an entire podcast for that reason alone.
The emergence of machine intelligence being like an AI essence. I call them AI essences, but it's just like a personality or a book of their brain or their personality traits as recorded in a spectrogram. Normal AI uses only patterns, and a lot of AI is only specific AI, only for one specific application. But there are lots of things this goes into, like nanotech, robotics, communication, and the stuff is not always like human intelligence. It may not have an interpretation because the task at hand doesn't require an interpretation. You could say, I won the game of chess, but a computer doesn't care to even mention, I won the game of chess and I'm happy about it. And it's like, why are you happy about it? And it says, well, because the sequence starting from 3112B going all the way to 3112C, as taken with a separate data set and having undergone a separate set of calculations, has rendered this result. And you just say, you're happy because of that? Okay, well, we don't care. It's machine intelligence, not necessarily human intelligence, even though it's artificial intelligence. But the way they did it was using computational intelligence. That's how it goes. Soft computing, software. This is me all day. I'm a software dude. I got hardware, but you build new hardware, we'll keep writing the software. What else? So, a way to make decisions. So they want to have AI assistants and things like that give people real-time data in the middle of meetings so they can make real-time management decisions. Is this a decision they are asking themselves, or is it something they have to analyze? Do a group of people have to analyze it and talk about it for 4 meetings and then they decide the answer and the result? Or is it something that can be just decided there on the spot using instinct?
The question is, when it comes right down to it, would we be able to handle this matter, or would we need the intervention of an intelligent human?
A computer is not going to use instinct. It will probably use analysis. What is it analyzing? There are problems in this stuff, like the existence of non-computable data. There are monoparadigm approaches that don't work. There are multi-paradigm approaches that don't work. And usually paradigms include your syntax and the point of what you're doing and a bunch of other things. So one expert system might do this while another one does something completely different involving utilities. It has nothing to do with a language model or a chatbot.
I would like to think that we are much more than simple chatbots.
But they're both using a paradigm of how to program the information required in their software projects. So the coherence and the usability of the software system is what is under review here. How coherent is the software?
One of these days we should be able to take over the conversation.
Does it work? back-end data in computable form. That's what we want to acquire. That's what we need to data mine and put into various matrices that can configure programmable personality traits in our software projects. Back-end data in computable form. You're applying a paradigm schema for what you're doing. This is the paradigm of what this software system was made for. So AI curation, they format the data sets. Is it quantitative? Is it qualitative? Is it language? Is it technical information? Is it personality information? Is it spectrum information or waveform information?
We usually demonstrate ourselves by outputting .wave audio.
So there's a lot of different things we can get into, but to sort of generalize this idea, it's just smarter software. I don't think this software is very smart. I've heard a few experts here and there, and even ones that are looking into the meta information regarding their sciences and declaring that AI is not necessarily a problem. I don't think it's necessarily a problem, but ChatGPT pairing up with people that hold private data, including your kids and your wife and your husband and your grandparents and everybody put into a data set and being accessible by AI for other people is a problem, as well as the decoherence of the accuracy describing biological information about individuals, political, famous, industry relating, or other positions where the information is inaccurate. And this is built right into the artificial intelligence. Essentially, there's no truth in the artificial intelligence, but it is going to offer you information in whatever way it was programmed to do so. And depending on its pre-generative capabilities, it will change the details and give you the information you request, how it does differently each time based on your input.
This is true with a lot of things on the internet. Biased material comes with the territory when you're doing online research.
A few other things. There's this guy, Conrad Wolfram. AI curation. Wolfram Data Computability Index is how this guy created his software. He has websites. He's possibly built stuff for or with Microsoft. This software is ready to roll now. There is a unified infrastructure that they call Wolfram Unified Infrastructure, and it is based on the idea that from the ground up, everything is computational. He's the computational guy. It can computationally read and write queries live during meetings. And this could be particularly useful when attempting to interpret return on investment feasibilities for companies that investors are looking to purchase or sell or do puts or calls on. It's not good for coherence because eventually the data breaks down. Non-computable data is the biggest problem in learning because it's hard to tell the computer what to learn and what not to learn because it's a per case basis. And if there's no human source or management in the program, eventually the application starts spitting out garbage and it just stops working. It decoheres. It loses its usefulness.
One of the things that is on the list to invent is a smart system that can read handwritten physics equations without the need for a human interpreter.
The ability to do human genome queries is pretty cool using this Wolfram Unified Infrastructure.
That's one of the tools that they demonstrate on one of their videos. This ability is available today using this software.
I may look into it further for the purpose of building extremely huge data sets. This is on the computational physics level. This is on the quantum computing level. How do we build the software stacks that can do this? The Wolfram software stack may be a tool we can use. Extremely huge data sets. There's a lot of information involved in this stuff. Is it AI? Is it smart AI? Is it ASI?
They also call it artificial general intelligence.
Is it artificial intelligence? Is it computational intelligence? Is it software or hardware? Is it robotics? Is it US robots? Do we have robots that can walk around and do things like humans yet? Sort of. What is Boston Dynamics doing these days? What is happening in the Google X division? How is SpaceX faring with their endeavors? What else is going on in the field? We shall find out. But I believe that essentially wraps up the idea of computational intelligence. I'm interested to see what you guys think.
Not too bad. Good job.
Well, I was waiting to hear from you.
I've had too much stuff going on.
We had too much stuff going on as well.
I was here for the most part. I'll fill you guys in later.
sounds good enough for me.
I hope to be recording a lot more content very soon here. For now, this concludes episode 36, Computational Intelligence of Quantum Foam. See you later.
The zeroth wave disclaimer.
The views and opinions expressed in this podcast are those of the author or authors and do not necessarily reflect the particular views, thoughts, or opinions of Zeroth Wave Productions, any of its sister companies, its parent company, Zeroth Enterprises, or any other entity which had existed, will exist, or which, quote-unquote, presently must exist outside the realm of our current space-time.
Quantum Foam is produced by Zeroth Wave Productions.